to the northeast, and yes, by the way, it really is called that, and the Moritomi Steel Bridge to the far southwest. Based on how spaced volcanoes are throughout Japan, there in theory should be between 8 and 13 active volcanoes in this gap. But there are none. Why? This becomes all the more confusing when you realize that the vast majority of Japan's 104 active volcanoes are indeed caused by partial melting of subducting tectonic plates which occur due to boundaries at these highlighted tectonic plates regions. So while you might expect a simple lack of a subduction zone to the southeast in this gap, this isn't actually the case here. There is still the exact same subducting tectonic plate here, that being the Philippine Sea Plate, as there is across all of Kyushu. And yet, while Kyushu's volcanoes are largely quite active with one eruption of the Ira caldera, specifically its Sakurajima vent, ongoing at the present, southern Honshu has only two very infrequently erupting volcanoes and then a large gap. So, since plate subduction is still ongoing here and there should be volcanoes, why isn't there any? Well, just because a subduction zone exists does not mean that many volcanoes will be created from its partial melting. There are numerous factors which determine the rate at which partial melting and thus magma generation and intrusions into the crust occur, largely owing to the composition of the subducting slab. For example, subduction factors: the denser a slab is, or the more volatile components such as water that it contains, the more magma it will end up generating. Also, the faster a subducting plate is moving, the more of it that will melt and eventually volcanoes and volcanic eruptions. This latter reason is largely why southern Indonesia has so many active and erupting volcanoes in comparison to the United States and Canada's Cascade Mountain Range. While the Australian plate, which is responsible subduction angle for many of Indonesia's volcanoes, is advancing northwards at a rate of 6 centimeters a year, the Juan de Fuca plate, which is directly responsible for the Cascade Range volcanoes, is only moving northeastward at a lesser rate of 3.2 centimeters a year. However, when it comes to discussing the aforementioned factors of density and amount of volatiles a slab contains, one aspect largely determines both of these. That being, the age of the subducting slab, specifically when the oceanic crust that composes it formed. You see, the older a piece of oceanic crust gets, the denser it becomes. Also, as the amount of time increases, the amount of volatiles, largely water, that get trapped in it, partially due to layer after layer of sediment accumulating on the ocean floor, vastly increases. And since both of these increase the density of a slab when it does eventually get subducted, it causes the slab to subduct at a much steeper angle than it would have if it was a recent piece of crust. In the case of our missing volcanic chain in Japan, this is the exact culprit. The subducting section of the Philippine Sea Plate responsible for Kyushu's volcanoes is plate subduction dated to approximately 50 million years old. Yet, the section of the Philippine Sea Plate between the western end of the Izu-Bonin volcanic arc and the Kyushu-Palau Ridge is dated to between only 15 and 25 million years old. This results in shallow subduction of the latter slab and deeper subduction of the former. However, volcanoes can form and still exist in the apparent gap, such as Daisen and the Kanabe Group, which both erupted within the last 25,000 years. Thus, while volcanoes can occasionally form in this gap, they are quite uncommon, especially since this highlighted portion represents the youngest part of the subducting slab. Thanks for watching. As a final note, I would like to thank this channel's patrons on Patreon and channel members on